Hi guys, quick video on the phases of the moon. This is Earth and Space number 4. So for this learning outcome here, you, the student, should be able to develop and use a model of the Earth, Sun and Moon system to describe the phases of the moon. Now first off, I want you to have a watch of this video here. It's on YouTube, Our World Moon Phases. Okay, and it is by NASA Eclipse. It is about, well, it's 3 minutes and 14 seconds long, exactly. Okay, so pause me, have a watch of that right now. Right then, so you've watched that. Now what you should have learned is that the moon reflects light. It doesn't generate its own light. The moon does not change shape. Half the moon is always illuminated. And as the moon orbits the Earth, our view changes. Very important here as well for naming the phases of the moon. Waxing means to increase or grow. And waning means to decrease. And then finally, the moon does one orbit of the Earth in 27.3 days. And that is about 1 month, and that's where the name month comes from, moon. Right, this is a nice image here. We have got our sunlight beaming in from the right-hand side. Now, I want you just to look at the inner circle here first, okay? Forget about the phases of the moon on the outside for the moment. On the inner circle, we can see that the moon is orbiting the Earth, okay? Now, on the outer images, we've got some images of the moon here, okay? Now, if you're standing on Earth, which you are, okay, when the moon is in this position, okay, you can see that like all of those inner positions, half of the moon is illuminated. But what you see from Earth is none of the moon illuminated, okay? That's because you're standing here on Earth, okay? And when you look at the moon, you can't see the side that's illuminated because it's facing away from you. Now, pay attention to these arrows, okay? There's little arrows there. This is the direction that the moon orbits, okay? So we go from a new moon to a waxing crescent, okay? That name comes from here, okay? A kind of sliver shape, I suppose. That is a crescent shape, okay? You can see you have a crescent shape there and a crescent shape there. So a waxing crescent means that more light is increasing on the moon as time goes on. So waxing crescent, well, means just that, okay? And that is that position there. Moving on from that, more light is being cast onto the moon. It is now at a 90-degree angle. The moon is there, the Earth is there, and the sun is way over here somewhere. And now from this position where you're standing on Earth, you can see half of the moon illuminated. And that's called the first quarter. Now, as the moon continues on, we've got the waxing gibbous. So again, waxing, more light is coming onto the moon. And gibbous is this shape, okay? Almost the opposite of a crescent shape. That's your crescent, this is your gibbous. Then next up, we've got our full moon. As you are standing on Earth here, you can see all of the moon illuminated. Now, once we go from a full moon, as time is going on, it appears that less light is on the moon. But again, as you can see from the inner circle here, half of the moon is always illuminated. It's just our view from Earth. So now we're on a waning, okay? So the amount of light is decreasing. Waning gibbous. Then we've got our third quarter, also known as a half moon. Then we've got our waning crescent. The light is still decreasing on the moon. And that is your crescent shape. And then you are back around to a new moon. Now remember, that takes 27.3 days to complete. Now, this is a nice little quick video on that. Okay, I'm not going to say much. I'm just going to let you watch this. This dot in the center here, that blue dot, represents the Earth. This represents the moon, and this is its orbit. And this over here is the phase as you are looking at it from Earth. And we've got our sunlight beaming in here. So when the moon is in this position, this is a new moon, we really can't see the moon. It's all in shadow. Okay, let's see what happens now. Right then. Okay, so what do we notice? Well, first of all, here we can see that we've gone from a new moon to a waxing crescent. The amount of light is increasing as time goes on, and that's your crescent shape. Okay, I'm going to press play again, and you will see over here, okay, the amount of light increasing again. So watch over here. Okay, the amount of light is increasing, and if the amount of light is increasing, we know it's waxing. And now we're at our first quarter. And we know it's the first quarter because the right-hand side of the moon is illuminated. Now we're going to keep on going. This is our gibbous shape, so waxing gibbous. Full moon. Now it's waning. Okay, so now the amount of light is decreasing that we can see on the moon. Then we've got our third quarter, our waning crescent, and then finally back around to our new moon. Okay, so have a look at that again. Okay, play and pause me as much as you want, and just analyze that orbit going around there and how the view from the Earth actually changes, or the view of the moon changes. And remember, half of the moon is always illuminated. It's just what we can actually see from Earth. Okay, really important. You need to know these names and the order that they come in, and you need to know the direction of the moon's orbit. Oh yes, hold on a second. Didn't you just learn during solar and lunar eclipses that here, okay, if the moon is in this position, we would have a solar eclipse, and here we would have a lunar eclipse? Okay, so big question. Why do we not get a solar eclipse once every month, okay, when we've got a new moon, and a lunar eclipse once every month when we've got a full moon? Okay, that doesn't really make sense, does it? Well, of course, there's an answer for everything, okay? And that is because the moon's orbit is tilted, okay? We can see here that as the moon goes around the Earth, orbits the Earth, it goes a little bit above the Earth and a little bit below the Earth. The tilt of the moon is 5 degrees. Now that may not sound like much, but it's enough. So this means sometimes when the moon is below the Earth, the shadow of the moon, okay, misses the Earth, so we don't get a solar eclipse. And sometimes the moon is up here and it's above the Earth, so we don't get a lunar eclipse. And you can see this nicely in this image here, okay? So we have got a new moon here, and you might expect that this would cause a solar eclipse. Because of that tilt, okay, the moon's shadow is not being cast on the Earth, it is going above the Earth, okay? That happens as well sometimes when the moon shadow is below the Earth too. Now that 5 degree tilt doesn't sound like much, particularly when you look at your protractor and you're like 5 degrees, that's like nothing, okay? And that's because this here image is the Earth and the moon to scale, okay? Because a lot of people think the Earth and the moon are actually really, really close together, but if you look at them to scale, they're really far apart. So 5 degrees is enough to make that happen. Now, next big question. Okay, whenever you look up at the moon, you always see the same face of the moon or the same side of the moon. Okay, this is a really nice image. We're getting a full 360 degrees image of the moon, but you never see the far side of the moon. Okay, you're used to, so we never see this side. We always see that side. Okay, so why is this? Well, of course, there's an answer to everything, isn't there? So to answer this question, why do we always see the same side of the moon? I want you to watch that YouTube video. Okay, there's a title. It is by T minus, and it's 1 minute and 43 seconds long, just to make sure you find the right one. So pause me right now go find that video. Right, you're back. You've watched that video. Now, the answer to our question, why do we always see the same side of the moon? That is because the moon's, I'm going to move myself up here, the moon's rotational period, okay, that's this here, the amount of time it takes for the moon to rotate once on its own axis, is the same as its orbital period, the amount of time it takes the moon to orbit the Earth. Now, just like I'm getting you guys to make it, okay, I like using models as well. I've got one ball here, okay, it's got a dot on it and an X on it, okay, and I've got a tennis ball here. Tennis ball is going to represent the Earth, okay, and I'm going to make myself a little bit bigger for this. Oh, I disappeared. Oh, I'm back. There we go. Okay, so this X is going to represent the far side of the moon, okay? The dot is going to represent the side of the moon that we always see, okay? So here's the tennis ball, and the X is facing you guys at the moment, and that's because the dot is facing the Earth. Now, as the moon orbits, okay, the moon also is rotating, okay? There's the dot, there's the X. This is a bit tricky to do on the video, but let's see if it's worth doing. Whoops. Okay, so as the moon orbits, okay, the dot, you can see it there now, is always facing the Earth all the time. And the X, the far side of the moon, is always facing away. Okay? I hope that model actually helped. Right, let's keep going. Sorry, so that's really a really important sentence. I'm just going to make sure that you paid attention to that. So the moon's rotational period is the same as its orbital period. Okay, success criteria for making your video, or sorry, making your model, okay? To demonstrate the phases of the moon, okay? Very important, all objects are labeled, okay? Label the Earth, the Sun, and the Moon. And I also want you to label the 8 phases of the moon, okay? Make sure everything's labeled. Light rays from the sun are shown, okay? And half of the moon is illuminated. And you should also show the view from the Earth with a capital E. You should also use arrows to show the direction of the orbit of the moon. And I would love to see a short video explaining your model, okay? As opposed to just a picture, I want you to explain it and show me that you really understand. So this is the success criteria for your model. Now, here are some models that I found online, okay? This is a really interesting model. So you're to stick your head in through here, and then you're to have a look at what you can see as you turn your head around, okay? That's a really interesting way of doing it. I'd like to see some of them maybe. But if you look at your success criteria, there are some things here that are missing, okay? We don't have any labels. The direction of the sunlight is not there either, okay? We haven't also shown the phases of the moon. Okay, here's another model here. Okay, here's the sun. This is a better model because it's labeled, but there's one thing that's a bit tricky on this model. It looks like none of the moon is illuminated in this position here. So they're only giving the view from the Earth. Okay? And even more strange, if you look at this one here, it appears that this wouldn't make any sense because the sun is here, but the other side of the moon is illuminated. So that's a bit of a tricky model. Here's a really good model I found. Okay, everything is labeled. Okay, we've got the inner circle here. We've got half of the moon is always illuminated, and then on the outer circle, the view from the Earth. Okay, so it's really important to distinguish those two. Okay, finally, a little bit of extra material, more so out of interest. Okay, this isn't technically speaking on our course, but if you've ever seen tides or you've ever noticed that the water has come in really far or out really far, and ever wondered why, this is the answer to that question. Okay, first of all, there's a really common misconception that tides are waves, and that is not true. Okay, surfers surf waves. Okay, tides are when the water, the entire body of water, moves up and moves down. High tide and low tide. So I want you to watch these two videos, okay, explaining tides. Ocean's Tides Explained, and then Space Science Tutorial, Spring and Neap Tides. Now you might say, well, why is this even important? Well, particularly in wintertime and in a lot of places around the world and in Ireland, when we're doing our weather forecasting and we're predicting predicting a lot of rainfall, so there could be flooding, we would also be watching, are we going to be on spring tides or neap tides? Okay, to see, are we going to have a really dangerous amount of flooding or maybe a little bit less flooding? Okay, spring tides are extra high and extra low. Neap tides are not so high and not so low. And these videos explain why that is the case. Write down your study checklist. Okay, make sure that you can answer these questions. Can you draw and label the phases of the moon? Can you put the phases of the moon, images and names in the correct order? Can you explain why we do not get a solar and lunar eclipse every month? And can you explain why we on Earth can only see one side of the moon? Okay, so I hope you found this video useful, and please go outside and check out the moon. There's also a really common misconception which I should address. The moon is up in daytime as well as nighttime, okay? It's just that it's more difficult to see the moon during daytime. A lot of people think that the moon is only rises at nighttime. Totally false. Right, please go outside. Hopefully you can see the moon. You can check online when the moon rises in your location and check out what phase the moon is in. Off you go.